In this video, we will create something completely useless but extremely cool. We will create a completely functioning tic-tac-toe game only using TypeScript types. Let's get started. So let's get started with the implementation. So we will start really easy. We will say we have a state here, and this is either X or O, or this could also be an empty space. Now we have our game board here, and now we will not make this complicated. We will just create an array here, and we will say this has a state in there, another one, and a third one. And we will do this for 3 lines. So basically this is just an array with 9 elements. And because this is just a simple array, we can work with this really easy and implement our game logic. So what is the game logic we will have? So the first thing we need to check is if we have the right amount of X and O's in our array. Because if you think of it, if you have, for example, 3 X's in there, but only 1 O, this is not valid because you always have to take turns, 1 X, O, X, and then so on. So we have to check if there are too many X's or O's in there. So check for amount of X and O. Now the second thing we have to do is, who is the next player? And we can easily do this by seeing if there are more X's or more O's in there. And because of that, we then can calculate what the next player is. For example, when we have 2 X's in there and only 1 O, then the next player will be the player O. Now, of course, we also need to know if somebody has already won the game. So we say here has won player 1. And how can we check this? Well, we have to check if in this array, certain elements are in a certain position. For example, we can check here if the array element 0, 1, and 2 do all have the same state. So if they all have X or O, then the game is over. And we have to do this for all the possible combinations. So for example, also for the vertical ones. So if the element on index 2 and the element on index 5 and on index 8 are all the same, and so on. So we need to check this somehow in our code. And the last thing we of course also have to do is we have to check if it's a draw. So because it can also happen that our game is over, but we don't have a winner. And how can we check this? Well, we need to check if there is still an element in there which has a space in it, because if not, then there are no more turns to be made and the game is over. So before we start to implement this logic, we have to implement some helper methods first, because this will make it much easier to implement our game logic. So the first thing what we will do is we will call this extends. So this extends will take a first element and a second one, and we will see if the first one is extending the second one, and if so, we return true, otherwise false. So we say, okay, if first extends second, then we return true, otherwise false. So we will use this right away, and we will create this type anyTrue. What this will do is we will pass like a check type. This can be any type we want, and we will then check if true extends this type we pass in. So what we say here is we say extends true, and then we say here our check. So why is this useful? Let me show you. So let's say we have our test here and we call anyTrue, and we have a string or a number, or let's say we have true in there. And when we now check if any of it is true, we can see that it returns true. If I pass in here false, then this will return false. So we can use it for like a contains. So let's remove this and create this contains type. So we create this type contains, and as a first type, it takes an array which is of type state, and as a second one we add a toCheck, because we want to check if this array contains this toCheck type. Now how can we do this? We just use extends again, and now we pass in this toCheck, and as a second argument we don't just pass in the array. What we now do is we pass in the array but use an index access and say number. Now what this will do is it will convert your array type into a union. So let me show you how this works. Let's say we have our array here, and this has a string and a number in there. Now when I check this, of course, this is just a string and a number array. But when I now say here number, it will iterate over this array and convert it into a union type. So because of that, we can now see if this toCheck here is extending this union here. So this will prove helpful later. So let's remove this type here again. And now let's create another really helpful helper, the len for length. And we pass in an array, which also is of type state here. And we just return the length of this array so that we don't have to call length all the time on our arrays. So let's now create the last helper type we need. So we create a same length helper type, an array 1, which extends state array, and we have our array 2 here, which also extends state. And now we want to check if they both contain the same amount of elements. So we can say extends the length of our array 1 is the same as the length of our array 2. And now we have created all the needed helper types. So now we are ready to implement our game logic. So the first thing we need to do is we check for the amount of x and o. So to do that, we have to take our array as an input and then check how many x's and o's are in there and store them inside of an array structure. So how can we do this? Well, first we create a new type. Let's call this type count. And we have our remaining board there, and this extends state array like this. And as a second argument, we have our x count, and this x count is of type x array because we only want to allow x's in there because we want to count how many x type strings are in our game board. And we initialize it with empty because at the start there are no elements in there. And we also do this for our o count, which extends an o array, which also starts empty. And now we can start to recursively call into this count type, because what we will do is at first we have our complete game board. Then what we will do is we will check the first element. We will check if this is of type X or O. And if it is, for example, of type X, we will add one more element to our X count. If it is of type O, we will add one to our O count. And otherwise, we will not add it at all and just recursively keep calling into this type as long as there are elements in our game board. So what we now say is we have our remaining board here. And we say, okay, as long as this remaining board extends an array which has an head element, so if there is still an element in there, then save the value in this head type and save the remaining part in our tail. And this is of type state array. So the first time we call into this, this will have all these 9 elements in there. Then we will take away the head and we will store the remaining part in our tail. So as long as this is the case, what we will do is we will just call our count again with our tail. And now we have to add another element to our x count or o count in case where this head is of type x or o. So what we say is if head extends x, then in this case, we take our existing x count elements and we pass in another x like this. Otherwise, we just use x count because we don't want to add another element because the head is not of type x. For the o, we do exactly the same. We say head extends o. In this case, we also spread our existing o count into it, add another o, or otherwise we just return our o count because we don't want to add anything to the o count as long as the head is not of type o. So if this is not the case, so if there is no remaining element in our array, we will just return our x count and our o count because then we have recursively called through our whole array. So because of that, we now can count how many elements of type x or o are in there. So let's check if this is working. So we have our type here, counter, and we have the count here. And let's create the board here really fast. So what we will do is we will just have here empty strings in there like this. And let's copy this. And now when we check the count here, of course, this should be 2 empty arrays. But as soon as I add an x in here, for example, we can see that we have 1x. If I add 2, we have 2x in there. If I add an o in here, we can see that we get 1o. So we have now created this count type, which we can now use to check for the correct amount of x and o. So let's remove this again. And let's now use this in our type. So we call this type correct xo. And what we pass in there is our x array, which extends state, and our o array, which also extends state. And now we will see why we created these helper types, because we can just say same length, x and o, because this will check if they both are the same, because this is correct. This can be a correct state. If there are the same amount of x and o, then just x is the next player. But there's also one other state which is valid when there is one more x than o, because always x starts playing. So for example, it's also allowed that there are 3x and only 2 o's, because then o will be the next player. So how can we check for this? We just say same length or another same length. But in here, we will do something interesting. We will say x is the same, but we will add one more element to the o's. So we will say we have our existing o's and we add another o in there. Why is this important? Because let's think about this. When x is one more than o, when we add one more element to the o, then they are the same again. So with this, we also cover the case where there is one more x and one less o. So for example, 3x and 2 o's, because this is also allowed. Now we have to wrap this in an any true because we want to check if one of them is true. So this correct xo will now return true if there is one more x than o's or if they are the same. So let's see if this is working. So we have our test here and we have our correct xo and we pass in, for example, 1x here and we have an empty o. And when we check this here, this should of course return true. We can see here this returns true. Now, if I add another O in there, this also returns true. But when I add another O, we can see this is false because it's not allowed that there are more O's than X in there. But if I now add another X in there, we can see this is true again. But when I add a third X again, this is also allowed because, as mentioned, it's allowed that one more X than O is in our game. Now we have done the first thing, we have checked for the amount of X and O. Now the next thing is we need to figure out who is the next player so that we can show in a message, well, X or O, it's your turn. Now for that, let me remove this type again and let's create a new one and let's call this who is next. Now we again pass our X, which is our state array here, and we pass our O, which is also our state array. So now we can use the same helper type as before, so we can say if same length of X and O extends true, this means that the next player is X, because let's say we have the case that we have one X and one O, then the next player is X because X always starts. So we can say here that X is the next player, otherwise O is the next player. So let's see if this is working. We have the test here, we have our who is next, and we have, for example, one X in there, and we have one O in there, and the next player of course should now be X. Now if we have here another second X in there, then the next player should be an O. So this is working perfectly fine. So let's remove this again, and let's now create the third check. So if one player has already won. What we now will do is we will check in this array for any possible combinations, which would mean that one player has won. So for example, index 0, 1 or 2 with the same state would mean one player did win, 3, 4 and 5 and so on. So what we first will do is we will create the all same type. We put in an array and we say this array is a tuple with 3 states in there because we want to check the values of 3 different indexes at once. So what we now do is we check if the array extends a certain shape. So we check if there are only X's or O's in there. So we say here X, X, and X, or if it's an array of O's. So we check if there are 3 O's in there. So when we have this, we return true, otherwise we return false. Now we can use this all same type to check for all possible winning conditions. So we create the type win check here, and we pass it our board, which extends our game board. And this part is a little bit boring because what we do now is we add all the possible combinations where someone could win. So we have this all same here, and then we have this array, and then we say board index 0, board index 1, board index 2, like this. Now because this could be the case, because if index 0, 1 and 2 all have X or O in there, then this would mean that one player has won. Now we have to do this for all the possible vertical, horizontal and diagonal ones. So let me do this real quick and I will be right back. So welcome back. As you can see, I've added all the possible combinations which will lead to a win. So the only thing left here is we need to wrap this in a any true here because we want to check if one of these conditions returns true. And now we can use all the types we've created and create our final game. So what we'll do here is we create the type here, TypeTacToe. And this takes a board which extends our game board like this. And now the first thing we need is we need to use our count type to get the X and O count. So we say here count board. And now we can say if this count board extends an array, we then want to figure out what is at index 0 and 1. So we say infer X extends state and infer O extends state like this. Now, when this is true, everything is fine and we can work with it. If it's not, this means our game is completely broken. So we say if this is the case, then everything is fine and we will continue. Otherwise, we return never because this should never happen. This is like a branch we will never enter. But in this case, we have access to our X and O. So the first thing we have to check is if we have the correct amount of X and O. So we pass in our X and our O, and we then can check if this returns true or false. If this returns true, our game is still working and in a working state, so there are not too many X's or O's in there. Otherwise, we have to show an error. So we say extends true. So in this case, we can continue. Otherwise, we have to show an error and we say too many X's or O's. Now, in the case where the correct X and O returns true, we can check for a win. So we can say win check here and we put in our board. Now, as seen here, this will return true if any of these conditions return true here. So we say if this win check board extends true, we have to figure out who is the winner. And we can use this who is next type here because this who is next also tells us who the last player was who did a move. And this is the player who did win the game. So So what we can say here in this case, if somebody has won the game, so we use our template literals and we say who is next, we pass our X and our O, and we say if this extends X, so if the next player is X, this means that O has won the game. So we say in this case return O, otherwise we return X like this. And we just add wins so that we can see who did win the game. Now, if this win check returns false, this means that the game is still ongoing. So we have to check if there are still empty spots in our board so that there are still moves possible. So we use contains here, we pass in our board, and we pass an empty string to check if there are still empty strings in our board. Then we check if this extends true. In this case, we need to check who is the next player. So in this case, we will then check for the player. Otherwise, we say draw like this because there are no more possible moves. But in the case where there are still empty spaces, we can use the who is next type. So we use a template literal again and we say who is next. We pass in our X and our O and we say it's your turn like this. And this is already it. So let's see if this is working. So let's create our type here first game. And this is of type TypeTacToe. It takes an array as its type argument. And now let's initialize the game like this, where we add 3 strings in there. And let's just copy these 2 times. And now we are ready. So let's see what the type here is. Let's check this out. We can see X, it's your turn. Now we say X starts the game like this. Then the next player is here with an O. Now we can see it's X turn again, so I add an X here. Now we can see O has to do its next turn, but what happens if I use an X here again? We can see too many X's or O's. So in this case, I for example say I have an O in here, now we have an X here, and let's do another O in here. And now if we add an X in here, it should show us that X has won the game. And we can see we get the result X wins. So we can see that the X wins works. But what would happen, for example, if I put an X in here, an O in here, an X in here, and an O in here? So to make sure that nobody wins, we can see that this results in a draw. So the draw check is also working. So as you can see, we have created a really cool tic-tac-toe game by only using TypeScript types. So thank you for watching the video. You can find the code to the game in the description below. And please also let me know in the comments what you think about it. And if you enjoyed watching the video, please leave a like and subscribe to the channel to stay up to date for the newest TypeScript stuff. See you in the next one. Bye.